The Data Encryption Standard, DE, was endorsed by the National Security Agency, NSA, from 1974 to 2002. For around 30 years, the DE algorithm ruled the cryptography world as the go-to encryption algorithm. The Data Encryption Standard, a type of encryption cipher, meaning a way to disguise information from unauthorized parties. The Data Encryption Standard, or DES, is an encryption algorithm that converts plaintext into blocks, then uses a key to convert it to ciphertext. DES is based on an earlier cipher by cryptographer Horst Feistel, called Lucifer. Developed in the 1970s, Lucifer was one of the earliest block ciphers. DES is a symmetric algorithm, meaning that it uses a single key both to encrypt and decrypt communications and other data. This is different from asymmetric encryption, which uses two unique keys to encrypt, public key, and decrypt, private key, data and communications. Well, although it's true that the DES algorithm is no longer used for security purposes, it is still the basis for other security algorithms. So, learning what DE encryption is and how it works will also benefit your cybersecurity knowledge and understanding of cryptography as well. As such, your knowledge of DE will help you understand how other encryption algorithms work. An basic look at how DES as a block cipher works by breaking your input down into 64-bit blocks and encrypting each block using a 56-bit key, 8 parity bits. The basis of DES is bits, that is, binary numbers, for example, zeros and ones. Hexadecimal, or base 16 numbers, are made up of 4 bits. To encrypt a message, the Data Encryption Standard creates blocks of 16 hexadecimal numbers, equal to 64 bits, using an encryption key. Encrypts 64 bits of plaintext blocks, and returns 64 bits of ciphertext. Performs 16 rounds of processing using Feistel function, more on it later, fortifies the encryption with additional initial and final permutations. The initial length of the key is 64 bits. However, every 8th bit is dropped, effectively making it a 56-bit key. Before being dropped, these 8 bits, known as parity bits, are used to check the two versions of the message and detect errors in the code. The initial length of the key is 64 bits. However, every 8th bit is dropped, effectively making it a 56-bit key. Before being dropped, these 8 bits, known as parity bits, are used to check the two versions of the message and detect errors in the code. So, with DES, a message is divided into blocks of 64 bits. One problem with this is that not all messages have a length exactly divisible by 64, so the last block might be smaller than 64 bits. This means that the last part of the message has to be padded with extra bits to fill the space. There are different methods of padding the messages. One method is to use zeros at the end of the message to fill the gap, and the numbers are then removed upon decryption. In conclusion, DES was a crucial encryption standard for many years and has played an important historical role in data security. Encryption is a part of our online lives, and understanding how it works helps us to stay secure.